Welcome. We're going to be talking about extreme weather today. I think we've all, especially since this is being recorded a couple of weeks after the big Texas fiasco, have noticed that our weather has changed. And there is maybe some effort to make it seem like it's all just normal. We've had this before, but there is a climate connection, and we're going to explore that a little bit today. So let me just share my screen with you and get this thing set up. Phoenix just experienced the hottest summer ever this last year with 53 days above 110. Now it's even worse than that. There's something called heat index, which takes both heat and humidity into consideration. Humans can't tolerate too much heat and humidity because we need to cool off our internal temperatures. I suspect that's true for pretty much every animal. But in 2000, there were 121 days with a heat index above 105 degrees, which is starting to be in the danger area. By 2030, we expect that number to jump up to 133. By 2050, that number goes up to 147 in Phoenix. This is according to Climate Central. And heat killed a record number of people last year. Over past 5 years, heat has been linked to more than 1,500 deaths in Arizona. Death Valley last summer hit 130. It was the hottest recorded temperature on Earth since 1931, although I looked into that 1931 and it's a little bit disputed. But still 130 degrees is pretty darn hot. This last year, in June in Siberia, for Pete's sake, temperatures reached 100 degrees. That's the northernmost 100-degree temperature ever recorded and the highest temperature ever recorded in the Arctic. You know those people don't have air conditioners. This is especially worrisome considering that La Nina years generally have cooler conditions in North America and Europe. Here's our big, strong La Nina system. This was in 15 October. And it was also coincided with a solar minimum. The sun goes through cycles. And since about 2017, we have been at the lowest ebb of the sun cycle, which means that a lot of the activity from the sun that might warm the earth is not happening. So that should cool us off well. But despite it all, 2020 may be one of the hottest years ever. The number of extremely hot days and nights in the Middle East and North Africa is approximately doubled since the 1970s. And we get things like this. In June of 2018 in Oman, the nighttime low was almost 109 degrees. Now, you can see a little ocean off to the back here, so you know that was a very wet 109 degrees. That's not survivable. If their electricity went out, these people would all die. Heat index, remember in Bandahar, whatever it is, in Iran, reached 165 degrees. This was in 2015, but it shows the trajectory. Now, if we look here at the heat index chart, you can see that we start getting into extreme caution areas when the temperature is only 90 degrees at 40% humidity. This doesn't even show 165. It must be somewhere around in here. This is absolutely lethal stuff, anything in the red. So it is a concern, and there's a paper that I'm not going to report on, but it did suggest that there are a few counties, Yuma and La Paz in particular, who are going to be vulnerable to this. India, summer heat may soon be literally unbearable. This was in July 2018. They've got that heat and humidity problem. Who's the most vulnerable? Well, obviously the poor and the homeless, but the elderly, infants, and children are also very susceptible. If you've got a cardiac or a respiratory condition or some of the other kind of challenging medical conditions, and of course the mentally ill, Pope Francis reminds us that the gravest effects of all attacks on the environment are suffered by the poorest. Now, these extreme weather catastrophes, and here we're talking about extreme temperatures, droughts and fires, floods and mudslides, and the storms that create them, have all been getting worse. This chart goes from 1980 to 2017, and it's published by Munich Re, which is a reinsurance company. Reinsurance companies insure the insurance companies. So they have a vested interest in keeping very close tabs on what the trajectory is for these very expensive, in a lot of cases, catastrophes. Kind of interesting to look at it. We can see that the storms, this gold bar here, 1980 compared to 2017, looks like it's probably doubled. This is up above, it looks like about 250, and this is maybe 125. So that looks like it's pretty much doubled. But when we look at the impact of floods and mudslides, whoa, holy smokes, it's about 4 times as much. Same thing with these extreme high temperatures, droughts and fires. These have gone way up as well, maybe 4 times as much. So the impact is getting greater. We'll talk about why that's true. Here's the linkage between the climate crisis and the increased frequency and severity of these extreme weather events. Number 1, global warming is contributing to an increased incidence of extreme weather because the environment in which all storms form has changed from human activities. In other words, all that heat in the atmosphere, all that heat in the system is translating into energy. Now, we can look at, this is a kind of an interesting little data set. This is the average 1951 to 1980. This represents a very stable climate. We have plus or minus here around 0 is the center bar. So most people experienced temperatures that they expected, what they were used to. There were a few people down to 3 standard deviations away from the center, cooler than average, and same thing with warmer than average. And you notice that 3 above and 3 below is pretty much as far as it goes. There's no real wild extremes. There are extremes, but they're not wild. So this green line, we're going to follow that. That represents that 1951 to 1980 mean. 81 to 91, you can see things are starting to shift to the warmer. 91 to 2001, they've shifted even further to the warmer, with kind of the middle being here mostly hot. But I want to point out this. Notice now that compared to the average, we're now down to almost 4 standard deviations, and compared to the middle, we're way off in terms of how much colder. It could be these really weird outliers like Texas. That's cooler. On the other hand, what we're seeing here is a lot more heat events. And as we move into 2001 to 2011, that's increasing even more. They used to cover 0.1% of the Earth, and now they cover 10% of the Earth. We don't have one for 2021 yet, but I hope that will be coming. Now, I want to talk, when I put this originally together this year, we were experiencing that big polar vortex that was going to come across Texas. And this was some information from CBSN that kind of explained it. They said sudden warming in the Arctic displaces the polar vortex. We heard for about a week about this big hot area just over the Arctic that was probably going to cause some problems, and certainly it did. But you can see this warm air has pushed the polar vortex down into the United States. Accompanying that came huge winds and wind chills along with it. So Fargo was like minus 35, Duluth minus 39, pretty uncomfortable. I want to remind you that we've talked about this before. The poles are warming faster than the rest of it, this Arctic amplification. So that's a part of the problem. And then we need to explain a little bit about the jet stream. Now, this is a lovely little video. You can do a search and find it. What happens in the Arctic doesn't stay in the Arctic. Nicely done, very artistic. But basically what it tells us is that the air, the atmosphere over the equators is thicker than it is over the poles. And the reason for that is because air is a gas, right? And at warmer temperatures, gases expand. At cooler temperatures, gases contract, and the difference between the higher pressure and the lower pressure is what drives this circulation pattern, and that's what changes the path, the speed, the character of the jet stream. As the Arctic is warming, there's no longer a really big difference like there used to be. And so that's made all of the jet stream much weaker. So as well as being weaker, a couple of things happen. One thing is it gets really wavy. Instead of just going around like this, the nice path, we're starting to see big dips up and down. And it also, because it's weaker, it tends to get stuck. And so in our case, what we might have a dry week or so during the summer, that could end up lasting for a month or more, turning it into a drought. Rain, instead of just raining for a little while and then the system moving on to the east, it can just sit and spin and flood. Same thing with snow. So back to our little polar vortex thing. This is normal. The Arctic oscillation, stronger, not so wavy jet stream, keeps the cold air north and the warm air stays south. But what's happened is this, what they call Arctic oscillation in a negative state with this wavy jet stream, weaker, wavier jet stream. Warm air flows to the north that encourages Arctic amplification. Cold air flows to the south, which gives us the problem we had in Texas. Now, ocean temperatures have also set a new record in 2019 and likely to set a new record again for 2020. I haven't seen those statistics yet. The reason that the oceans are warming is because 93% of extra heat trapped by man-made global warming pollution is being absorbed by the ocean. As oceans warm, they evaporate even more moisture. And that warmer air can hold a lot more water vapor. With each additional 1 degree of temperature warming, the atmosphere's ability to hold water vapor increases by 7%. So we are already 4.5% greater water vapor over the oceans than there was 30 years ago. And all that water vapor doesn't stay nicely and easily distributed. What it does, the winds move it around and you can end up with these atmospheric rivers. This one, there's been some atmospheric rivers since then. We had one in 2020, but this was a particularly notable one. California had been in drought for several years. There was water rationing in some of the communities. The reservoirs were at dangerously low levels. And then all of a sudden, February 20th comes, they have about 3 or 4 days of very intense rain. And they actually had some fear that one of the dams were going to collapse because of too much water behind it. It also creates these situations. This particular kind of a storm is called a bathtub drain storm. And the conditions become right for rain over a certain area, but because there's so much atmosphere in, so much water in the atmosphere, it doesn't just drain like a bathtub. When you open the plug, it doesn't just drain what's above the drain, it drains the whole tub. And that's what happens here, which means that the rainstorms and the snowstorms are getting bigger and more intense. As I'm recording this, there is an enormous snowstorm that's, I think, just about finished up in Colorado, and some places have had up to 4 feet of snow, some of the mountain passes, and I'm quite sure that this has something to do with that. But this causes bigger and more frequent floods. For example, here's one. In the Uttarakhand state of India. Now this was 2013. I just kind of happened to like this picture, and we're going to talk about this state again in a minute. But early June rainfall was over 400% above average. So these are happening. I can pull these off from every year since 2013, and I started getting the data. It can happen here. This was a picture in Phoenix. You can see this is probably on I-10. All those cars flooded out. Bangladesh, this was from May of last year, 2020. Bangladesh is particularly vulnerable to this because there's a lot of it that's a low-lying delta area, and that's the area is called the Sundarbans. The Sundarbans is finished. Amphan, that's the recent cyclone that hit, has killed it. All our crops, even our trees have been destroyed. What will we do? And when you have these intense rainstorms, they're often accompanied by these big landslides or mudslides. This was one that hit Nepal in September of 2020. 30 people dead or missing. This was a kind of an interesting one that hit in February of 2021. This was back in our Uttarakhand state of India, poor state. 14 people confirmed dead, at least 170 others missing. Now, this was on February 7th. They said part of a Himalayan glacier broke away, setting off a torrent of water, rock, and dust down a mountain valley. This is upstream looking down and downstream looking back up at this thing coming at them. The next day, though, there was a New York Times article that said that in fact what had probably happened based on satellite images was that it was a collapse of an equally high rock slope. Whatever it was, it took out 2 hydroelectric dams and did a pretty significant amount of damage. And of course, all of the evacuations that take place with these right now, there's a dual challenge. A cyclone, a mudslide, it's all happening during COVID, and now there's dual problems of trying to help these people and keep them safe from each other, from the virus. All of these cost money. 1980 to 2019, the average cost for the year for these weather and climate events, looks like here maybe $7 billion, which is not nothing, but you can see how that's changed. So 2016, 2017, 2011 kind of hit the top mark here. Looks like $17 billion. By late August of 2020, we had already reached that. They are becoming more severe, and as a consequence, they're costing us more money. You might remember this was in 2019. In the spring of 2019, there was huge flooding in the Midwest, figured about $12.5 billion this spring. The Hill reported that the Congressional Budget Office predicted that just hurricanes and flooding alone were likely to cause $54 billion in damage annually. So we are not going to have to pay nothing. You know, sometimes you hear people talk about, oh, it's too expensive to fix this. We are going to be paying regardless. In terms of cost, the 2020 hurricanes, the expectation is about $38 billion, 2019, $3.4 billion, $25 billion in 2018, $265 billion from the 2017 hurricanes. Of course, that was Harvey and Irma, and that's where a lot of lives ended up being lost as a result of it. But you can see lives are lost all the way through here, nearly 100 this last year. So let's talk a little bit more about hurricanes and their issues. There's a word here we need to talk about. The word is anomalies. This is it's a fun word. It's kind of fun to talk about it. So an anomaly is the difference in a particular place at a particular time between the temperature then and an average based on 20, 30, maybe even 100 years data. In this case, we're looking at 30 years, and they always give it to you if you're talking anomalies. So this is 1961 to 1990. That's the 30-year average. So when we look at this, this is the Gulf of Mexico. And here's our scale down here at the bottom. You can see this really brick, dark, almost black red, and getting close to it is up here in the neighborhood of any place from, like 2 degrees to up to 6 degrees centigrade above average. And you can see that this water right before Hurricane Michael was extremely warm compared to the average. Well, remember, we said that there's more energy in the system, and that energy in the system makes things worse. So they create stronger storms. The warmer air, the warmer sea surface temperatures give that more energy. We also said warmer air holds more water vapor, so they'll be more available to when it starts to rain, and the weakened jet stream isn't pushing systems away as fast, and that all came together in the Houston area. They had 5 days of rain after Hurricane Harvey. It just sat over the top of Houston and poured water in. It was a 1 to 25,000 year event. In some nearby areas, it was a 1 to 500,000 year event. And of course, this was the Houston Chronicle about a year later saying, even after Harvey, Houston keeps building new homes in floodplains. You know who's going to be buying those homes. Those are people who can't afford expensive housing. They will get in there and discover they've got really high flood insurance and that their homes may be continually flooded. Hurricane Michael destruction was mostly from the wind. I can remember seeing this with reports of that. Here was a whole town completely blown off the map, except for this one house right here on the beach. They clearly did not build to the Panhandle's weak building codes. They said, we believe in global warming. We are going to build for what we know will be much more extreme weather. Their house stood, the rest of them are gone. Here's another one. This was from Hurricane Florence. This was in South Carolina, I think. But it was a little map showing every Hurricane Florence related incident. Waste lagoons, wastewater treatment plant overflows, coal ash spills, petroleum leaks that was reported or investigated. Now, it does not, this is a big pig farm area. I read reports at the time saying the pig farms were flooding. They were sending all of the really nasty water that was coming off of them downstream into the communities that were flooded closer to the coast. And the floodwaters were bringing with it strains of antibiotic resistant bacteria. So stormwater drainage is something we are going to need to invest in. That is another expense we need to face. So moving on from too much water to too little water, this is based on a model of the way drought conditions are expected to go. Now this is where we are at 2000 to 2009, and you can see a band right across here where it's dry. For whatever the reason, some real concerns down here in the Amazon rainforest. And there may be some places that are just getting too much water. So the projection on this by the time we get to the end of the century is that this band across here is going to get considerably worse. In fact, extreme dry in this whole Middle East area and Southern Europe. Look at poor Spain, which has been having a lot of trouble with wildfires anyway. France, I don't know how you grow wine in a place like that, but I don't know how you grow corn in the in our Midwest. And look what happens to New Mexico to Mexico and Central America and the Amazon. The projection is not a good one. Going to take a look at some of those Central American countries because they're already experiencing some pretty extreme weather. Recent drought has led to the loss of some 280,000 hectares of beans and maize in Guatemala, El Salvador, and Honduras. That affects the food and nutrition of more than 2 million people. Now, this was published in 2018, but they have had, it's kind of worse than 2018 for them. So there is Mexico, and then here's the Central American countries. You can see this one has to do with climate change severity, and they're kind of more looking at heat index. But outside the comfort zone, this whole area right here, when they're saying comfort, they're meaning what can you survive in. We don't have anything here that looks like far outside the comfort zone, but pushing and significant changes, this is a big concern in that area. 40 to 45% of these people are rural, many below poverty. In 2001, irregular rain impacted their crops, and by 2009, drought with major agricultural impacts, followed the next year by really intense rain and then an extended dry period, which wiped out their crops. 2011, they had extended torrential rain, wiped out their crops. 14 to 18, they had drought, and then by 18, they'd had 5 years without crop production, followed in 2020 by 2 major hurricanes. These people are not creating climate change. Their emissions are negligible. We can change things. They can't. They can only try to respond and survive as best they can. It is no surprise and no wonder, and not of their own fault, that they are fleeing to someplace like the United States. So here's the U.S. Drought Monitor. January 2012 to January 2021, you can see there was a drought here, but the Four Corners states, our Colorado River compact states, we were affected, but not severely. Compared to January 2021, we are in exceptional drought. South America's got a big problem with drought too. And that's a big problem because we rely on the Amazon basin as a big carbon sink to help absorb a great deal of this excess CO2 in our atmosphere. Now, there are impacts of drought that compound, they get worse. One thing is, as the temperatures increase, evaporation increases. That, as temperatures increase, there's a change in precipitation. It generally decreases. So we've got increased evaporation, decreased precipitation, and as these increased temperatures, then we're going to have greater electricity demand for air conditioning. At the same time, these higher temperatures reduce transmission line capacity, they reduce transformer and substation capacity, they reduce reservoir volume and hydroelectric production in some of our dams. They increased water demands in order to create electricity, make it more challenging here. So, and let's see. Oh, and here's the other one. Range and forest fire damaged transmission infrastructure. We saw a lot of that in California. Unfortunately, if you're in one of these really hot, high temperature things, and a forest fire gets started and burns down your transmission line, you could be for an extended period without air conditioning, which could be fatal. So this is worth paying attention to. And the fire is a real issue. Hotter years have more fires. You can see there's a strong correlation here between a really hot year and the number of fires. And this only goes to 2018. We know that in California, the fire season was really bad in 2019 and 2020, but it was also bad in the Amazon rainforest. In 2019, fires increased by 84%. 2019 and 2020, there were deadly wildfires in Australia. You can see the map here. This 2019-2020 season, this last one, this happens around Christmas time. That's the peak of it. That's kind of their summer. And they were suffering. I have relatives there. They were all having trouble breathing because of all the smoke in the air. And of course, we saw the smoke from the fires here in Arizona from last fall. This is happening regularly in California now. One of the things that contributes to that, it's one of those feedback loops. As the temperatures rise and as precipitation falls, bark beetles move into these already stressed trees, and they kill them. And now you've got a bunch of dead trees in a forest that is burning, and so there's almost no way to stop it. Just want to spend one last little bit of time talking about this Arctic amplification, because it is having a major impact on the northern regions of this planet. Here's a nice example. Muir Glacier, Alaska. They're all taking pictures of it in 1880. By 2005, if you stood in that same place, this is what it would look like. And here's a fun one. Now, let's see if I can. Looks like water under there. He's in the tundra. He's going to break through the surface, get some of that out. But you can see it's not water. That is gas flowing out of there. That is methane gas. The tundra is thawing, and the methane that is locked up in the tundra is now coming out. Sometimes it comes out like he just showed. Sometimes it's actually kind of an explosive. This is an unusually large explosive crater, but this is a methane crater. The reindeer herders were coming back. I was reading reports of them in 2013 coming back going, hey, there's all kinds of holes out there. What's that about? There is a lot of methane stored in the Arctic. So we end up with what's called climate feedback. We release carbon dioxide, and that causes the earth to get hotter. That thaws the tundra. It heat stresses the forest. By the way, we're having lots of forest fires up in the northern latitudes that we never used to see before. It thaws the methane hydrates, lets them come out of a crystalline structure and become a gas, and it warms the ocean, all of which contributes to a release of even more carbon dioxide and methane, which makes the earth hotter, which intensifies that whole loop. At the same time as the earth gets hotter and the sea ice melts, what used to be a white reflective surface is now a dark absorbent surface that absorbs even more of the heat, which all in turn gets the earth hotter and encourages this feedback. So if you're with a group and you can have a discussion, these are just basic questions. Data integrity, I've tried to let you know where my data is coming from, but you might have a chat about it if there's anybody in your group that has a concern about anything that I've presented. What are your key reactions, your key takeaways? Maybe chat a bit about what you learned that will help to reinforce it in your memory. Do you need any further information? Is there anything you'd like to look up and report back to your group? And then really important one, what can you do to help on this? And I would think I would hope you would talk a little bit about policy. How can you help your legislators build political will to take action on reducing the emissions that are causing climate change? Thank you very much for joining us today. Hope you'll find some of the other videos on this series and take a look at them as well. Bye now.